Hello, guys, and welcome back to my channel, Aviation Mentors. And guys, in today's video, we will be starting a very interesting topic. So, what today we are going to start is something very important also because a lot of questions. This topic is very deep. I mean, this topic you will be asked in interview a lot of questions from this topic, and also in the navigation exam, a lot of questions will come from this topic, and this is very interesting topic as well. So today we are going to start basic navigation. Okay. So this is a very big topic. So what I'm going to do is I will be teaching you in a very short videos. So like you have seen in my previous videos of critical point and point of no return, those are long videos, but I'm going to try and keep it short and just give you a bit of information in each video, okay, so that you can fair it up and revise it. So in the basic navigation, guys, so what today we will be doing three topics. Okay, so the first one is the shape of earth. We will understand this. Second, we will understand what is the tilt angle. Okay, what is the tilt angle of the earth, tilt angle of earth. And the third topic which we will understand today is great circle. Okay, so these are the three topics which we will cover in the today's video. All right. So let's just start with the shape of Earth, guys. So what I'm gonna do is I'm gonna take one shape, and hey, understand this. Okay. So this question comes in DGCA, and you should also know as for the general knowledge. See, question is what is shape of Earth? Okay. Now a lot of you will say it's a circle, it's an ellipse. No, it is neither a circle nor an ellipse. What is the shape of Earth? So the answer to this question, guys, is the shape of the Earth is known as your oblate spheroid, or you can call it ellipsoid. You can call it ellipsoid, not ellipse, ellipsoid or oblate spheroid. So very important these two terms. This will be a 1 mark question in the exam. What is the shape of Earth? So the answer to the shape of Earth is the shape of Earth is oblate spheroid and ellipsoid, whatever is given in the option. Now understand this. What do we mean by this? So have a look here, guys. So suppose if I draw this, okay, let me just grab a normal pencil. Okay. So if I draw a circle, guys, suppose this is a circle. Okay. This is a circle. So, to understand what is ellipsoid or what is oblate spheroid, consider this. This is a circle. Now, in circle, this this is the diameter. So, this diameter, if I take this complete diameter as x and this diameter I take it as y, then x diameter is equal to y, because this is a circle, right? So the it has equal diameters. This is equal, or whichever line straight line passing through the center will be equal, right? So x is equal to y in a circle. Now Earth is oblate spheroid. Oblate spheroid means, have a look here. Oblate spheroid, suppose this is a perfect circle, and if I compress it from below, okay, see, this is oblate spheroid. So what happens is your this diameter, okay, I'm gonna take it with a different color. Okay, so let me just, yeah. So this diameter is longer than your this diameter. Okay, so from the center, so this is, I'm calling this as oblate spheroid, or I'm calling this as the ellipsoid. This is known as your ellipsoid. Now, Oblate spheroid or ellipsoid, it is compressed. It is like you have compressed the circle from above and below. It is compressed. Okay. So when you compress, it becomes big, or it becomes more in diameter from the between than from the upwards. Okay, so this is a two-dimensional picture, guys. So if you imagine this in three-dimensional, I'm going to show you a three-dimensional picture as well in a short while, but understand this first. So if you compress it, it becomes longer in the middle as compared to your this axis. Okay, so now guys, this is known as the oblate spheroid or the ellipsoid. Now, this diametrical line, this line is known as your equatorial diameter. Okay, because it passes through the equator. We will, don't worry, we will study each and everything in detail. I'm going to tell you what is equator and everything. So, just to understand this, this is your equatorial diameter, and guys, this is your polar diameter. This is your polar diameter. And as you can see, your polar diameter, it is less than your equatorial diameter. Your equatorial diameter is more than your polar diameter in case of earth. तभी तो, that is the reason the shape of the earth is oblate spheroid. अगर दोनों सेम होते तो सर्कल हो जाती. If they would have been same, it would have been a circle. So equatorial diameter is more than your polar diameter. Okay, so as you have seen, what is oblate spheroid or ellipsoid? So this is the shape of earth. Okay, so you need to remember this thing. This will come as a 1 mark question. So let me just highlight this for you guys. So this is your polar diameter, this is your equatorial diameter, and the shape of the earth is the oblate spheroid or the ellipsoid. And it is because compressed. Okay, compressed, because if you remember this word compressed, you will easily know that your equatorial diameter is more than your polar diameter, because when you compress, the equatorial becomes more than your polar, because polar is coming down less. Why? Understand this thing. Now we will calculate two things. So we have done the first thing that we have done is the shape of the earth. Okay, so the shape of the earth is ellipsoid. Shape of the earth is ellipsoid or the oblate spheroid. Oblate spheroid means which is thick from between, or in between it is more thick than from the top and the bottom. So next thing we're going to do is the some values. Now your equatorial diameter, guys, the equatorial diameter is nothing but 6888 nautical mile. This is the value of your equatorial diameter, and you have to remember this, guys. You have to mug this up. You have to remember this: 6888 6888 nautical miles. And your polar diameter, guys, your polar diameter is 6865 nautical mile. This is your polar diameter. Now guys, these two values you have to remember, because they will come as a 1 mark question to you in the exam, and I'm going to highlight it with another marker. So have a look here, guys. Okay, 6888 nautical mile and 6865 nautical mile. Okay, now have a look here. Now, guys, there is another thing which is known as your compression ratio. This is asked in DGCA exam lot of times. Now, from the word itself, you can come to know compression ratio. How much, how much Earth is compressed? How much Earth is compressed? This is known as your compression ratio. Like I have told you, if it would have been a perfect circle, so have a look here. So I'm gonna again take up a shape, guys. Okay, and have a look here. If would have, so this is your perfect circle. Okay, this is a perfect circle. But if I compress this, have a look here. If I'm compressing this, it becomes thick from between, and your polar diameter is decreasing and equatorial is increasing. Okay, so see, this is the perfect circle, and now I'm compressing it from the bottom. You see, it becomes oblate. This is the meaning of oblate. Oblate means getting thick in between. Oblate. Okay, all right. So how much Earth is compressed? We will calculate it. So now, guys, first of all, have a look here. Now, in your equatorial, okay, the spelling is wrong. Let me correct it for you. All right. So your diameter, equatorial diameter was how much? It was 6,888 nautical miles. All right. Now your your polar diameter was 6865 nautical mile. So what is the difference between your equatorial diameter and polar diameter? So it is, if you minus this 6888 minus 6865, it comes down to be 23 nautical mile. So guys, this is the another thing they will ask you in DGCA examination, that what is the difference between your equatorial diameter and the polar diameter. And you should see, this is very simple. You remember both the values, and you can also straightforward remember this. 23 nautical mile is your answer. Okay, 6888 nautical mile minus 6865 nautical miles, so it comes down to be 23 nautical miles. Now guys, this question is sometimes asked in a way that equatorial 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 diameter is more than polar diameter polar diameter polar diameter by how much? So by how much? The answer is your 23 nautical mile. So guys, we will do one video, complete video on the conversion of the unit. But just for now, remember this: 23 nautical mile is also 42 kilometers, and it is 27 statute mile. So you remember these three values. So if any value is given in the option is the correct value: 23 nautical mile, 42 kilometers, or 27 statute mile. Okay, now let's get back to our compression ratio. Let us just find out how much Earth is compressed by. So guys, very simple. Your compression ratio is nothing but your equatorial diameter minus your polar diameter divided by your equatorial diameter. Okay, so this is our compression ratio. So let us just put the value. We have know that this is 6888, this is 6865 divided by 6888. Guys, now this comes out to be 1 upon 297. If you calculate this, this comes out to be 1 upon 297. So this is our compression ratio, and sometimes we round it up to 300. So we can also take it as 1 upon 300. So if in the option you see 1 upon 300 is given, so it is also correct. 1 upon 300 is also correct. Okay, and 1 upon 297 is the exact, but sometimes in the question the answer will be given as 1 upon 300, which is also correct. This is rounded up to 1 upon 300. Now this is the ratio. Now what is the percentage? So compression ratio percentage. How much percentage it is? Simple, 1 upon 300. Let's get the percent. Okay, so this comes out to be 0.3%. Okay, so let me highlight this, guys. Compression ratio percentage is how much? 0.3%. Ratio is how much? 1 upon 297, which is rounded up to 1 upon 300. Okay, all right. Okay, this is the formula for your compression ratio, which is your equatorial diameter minus your polar diameter divided by your equatorial diameter. Guys, sometimes what they will do, they will in exam, they will give you their own value of equatorial diameter, polar diameter. So you use this formula. So you need to this formula use this formula to calculate the compression ratio. All right. So guys, we have studied about what is the compression ratio, what is the equatorial diameter and the polar diameter, and what is the shape of the earth. Okay. Now let us do one more thing about the tilt angle. So how much your earth is tilted and what is our tilt angle? To understand this, guys, I'm going to draw a shape around here. Just a second. Okay, shapes. All right. So have a look. So let me just draw. Suppose this is your. Okay. All right. This is the earth. Okay. And now I'm going to take up a axis. Just a second. Okay. So I'm going to draw some lines out here. So this is the one line I'm going to draw, which is perpendicular. Okay, and I'm gonna draw two planes. Okay, I'm gonna draw two planes. Just a second. Okay, I'm gonna draw two plane for you guys. This is the one plane, so I will take up the different color. Okay, all right. So this is the one plane I will draw, and I will explain you about all these plane. This is actually will be better understood in a 3D image. I'm going to show you the 3D image also. First I will explain you in the 2D, and then I will show you the 3D image. So this is the one plane which is surrounding the earth, and this plane we will call, or this plane, it is called the ecliptic plane. Okay, ecliptic plane. I will explain you what is ecliptic plane. Okay, so this is your ecliptic plane. Now, guys, the Earth is tilted. It is not uh, straight on its axis. So, how much Earth is tilted? We will be talking about it. So, suppose this is the okay. I'm gonna redraw it. Just a second. Okay, all right. So, yeah, this is the line I'm trying to, draw it better for you guys to understand it better. All right. So this is the North Pole. Guys, this is the North Pole. This is your north, and this is your south. Okay, this is your north, this is your south, and this is your rotation axis. This Around this axis your earth is rotation axis. All right. So now, guys, this axis which we have taken, this axis is also known as your perpendicular axis or normal plane. So I am going to write it down. This is your normal plane or perpendicular axis. Perpendicular axis. And why it is known as your normal plane or your perpendicular axis? Because guys, this ecliptic plane, now this ecliptic plane is a plane which is ecliptic plane is nothing but your plane of orbit. Plane of orbit, this is the orbit around which, this is the orbit in which your earth is rotating. Okay, now we have talked about two planes. One is the ecliptic plane, which is dotted in the green around. So ecliptic plane is the plane of orbit, or the plane around which the earth is rotating. Okay, so this is the orbit in which the earth is rotating. So let me just to just get you a better understanding. So earth is rotating in this plane like this. So earth is rotating like this. Okay, and earth is rotating on its own axis. So this is north, this is south, this is your rotation axis, which is passing through the north and south. Now we have drawn one plane perpendicular. This is the normal plane which is perpendicular to your plane of orbit or the ecliptic plane. So now guys, earth is, now if you talk about this, so suppose if I just draw a line out here, I'm going to draw a line out here. This complete is 90-degree. Now, guys, this much tilt of the earth. So, the tilt of the earth from the rotation axis, to the normal plane is 23.5 degree. And the tilt of the earth from the rotation axis to the ecliptic plane, now this is your ecliptic plane, right? This is nothing but your 66.5 degree, because this complete is your 90 degree. Okay, so this is kind of confusing, so I am going to show you a 3D diagram also. But because if you understand it in 2D diagram, it will be easier for you to understand in the 3D diagram. So have a look here. So we have talked about the three axes, so let me explain you again. We have talked about the three axes. First, I have taken the normal plane, okay, and the normal plane, and we have talked about the ecliptic plane. So, in the question, they will ask you, so the question will be like the Earth's tilt angle, okay, Earth's tilt angle. So, if they ask you Earth's tilt angle with respect to Earth's tilt angle with respect to normal plane, then the angle, tilt angle with respect to normal plane, just a second. Okay, normal plane. Okay, if they ask you this, then you can easily draw a diagram like this. This is your rotational angle, this is your normal, and this is your ecliptical. So this is your 23.5 degree, and this is the remaining 66.5 degree. So normal plane के साथ कितना एंगल है? Normal plane के साथ हमारा एंगल है 23.5 degree. So this is your answer. And if they ask you question, what is the earth's tilt angle, what is the earth tilt angle with respect to with respect to ecliptic plane? Okay, they can ask you with respect to ecliptic plane. Just a second, I have written the angle there. Okay, just a second. All right, so if they ask you with respect to the ecliptic plane, then what will be your answer? So अगर ये ecliptic plane के लिए पूछेंगे, then it would be 66.5 degree. So we have the two tilt angles, okay, with respect to the ecliptic plane and one with respect to the normal. Okay guys, now one thing I want you to remember, I will explain you what is the ecliptic plane, and I will also explain you the normal plane. Guys, now see, this is Earth is orbiting around sun, right? So suppose this is your sun, ये आपका sun है, ठीक है? Now Earth is revolving around the sun in the orbit, right? So this orbit, ये आपकी अर्थ है, so earth is revolving around sun in this orbit, ये रिवॉल्व कर रही है सन के अराउंड इस इक्लिप्टिक ऑर्बिट में, दिस ऑर्बिट, जिसको कि हम लोग और इसको ऑर्बिटल प्लेन भी बोलते हैं, दिस इज नोन एज योर ऑर्बिटल प्लेन, ऑल्सो दिस इज नोन एज योर इक्लिप्टिक प्लेन, ओके, इसी को इक्लिप्टिक प्लेन बोला जाता है, ऑलराइट। एंड अब बात आती है, सर यू विल आस्क मी सर, ओके ऑर्बिटल प्लेन समझ आ गया, ऑर्बिटल प्लेन इज नथिंग बट द प्लेन इन विच द अर्थ इज मूविंग अराउंड सन, moving around the sun, all right? Now but you will ask me, sir, then what is the normal plane? Guys, normal plane is nothing but the plane which is perpendicular to your ecliptic plane. So ये देखो, ये ecliptic plane हो गया। अब इसके नॉर्मल में अगर एक प्लेन बना हूं, अगर मैं 2D में बनाऊंगा, तो सपोज ये मेरा एक एक्लिप्टिक प्लेन हो गया, सो मैं इसको आपको शेड कर देता हूं। सो ये मेरा ब्लू कलर में, ये ब्लू कलर में पूरा मेरा क्या हो गया, इसको ये 3D है। सो ये ब्लू कलर में, दिस इन द ब्लू कलर is nothing but my ecliptic plane, all right? So this is my ecliptic plane. So now if I draw a perpendicular, so first imagine this in a 2D. So this is my normal, all right? And if I want to draw a plane, so this is the plane, this is the plane which is normal to your ecliptic plane, and this plane is known as your normal plane, okay? This is known as your normal plane, or it is known as your perpendicular plane, okay? So this is your normal plane or the perpendicular plane. So normal plane is nothing but a plane which is perpendicular to your ecliptic or the orbital plane, okay? सो गाइज, ये तो हो गई आपकी प्लेन की बात। अब इसको समझो 2D डायग्राम में, सिंपल एग्जाम पॉइंट ऑफ व्यू से। सो व्हेन दे आस्क यू, यू जस्ट रिमेंबर दिस डायग्राम। सो सपोज दिस इज योर अर्थ, ओके? सो आई एम टेकिंग दिस एज योर normal plane, okay? And this is my ecliptic plane, ये वाला जो है, ये मेरा हो गया नॉर्मल प्लेन, दिस इज माय normal plane, and this angle is my 23.5 degree, and this is my 66.5 degree, and this is my plane of rotation. This is my plane of rotation, a plane of rotation. This is the plane of rotation of the earth. The earth is rotating on its own axis, right? So ये होता है अपना plane of rotation, या फिर आप इसको बोल सकते हैं rotation axis, okay? So ultimately what you have to do is just remember these two values, 23.5 degree from the normal plane and 66.5 degree from your ecliptic plane or the plane of orbit, फिर इसको orbital plane भी बोल देते हैं, orbital plane. So guys, this was all about your tilt angle of the earth. Now we will talk about the rotation of the earth, in which direction the earth is rotating. So guys, if we talk about the rotation of the earth, rotation of earth, so guys, rotation of the earth के बारे में बात करते हैं। So suppose this is my earth, okay? This is the north, this is the south, this is the west, and this is the east. So guys, the earth is rotating from west to east. So ये जो है west से east rotate कर रही है. So earth is rotating from where? It is rotating from west to east. Now guys, if suppose you are a person, and now what I'll do is, one time I will ask you to go to North Pole, and one time I will ask you to go to South Pole. So suppose you go to North Pole and you are standing here, and one time you go to South Pole, and okay, so here you are standing on the South Pole. You are standing on the South Pole. So guys, first important thing is the earth is rotating from west to east. This is the important part you need to remember. West to east जो होती है earth rotate करेगी. And if you are standing over the North Pole and looking down, so you can see, if you're looking down from above the North Pole, it seems that the earth is rotating anti-clockwise. Okay, it is rotating anti-clockwise. So from the North Pole, it is, if you see from the North Pole, it looks like it is rotating anti-clockwise. And if you are standing on the South Pole and you look down, it feels like इट इज रोटेटिंग क्लॉकवाइज. फिर ऐसा लगेगा कि ये तो क्लॉकवाइज घूम रही है. Okay, now you will get confused, sir. From the south pole, how it is rotating clockwise? So do one thing. When you're watching this video, just flip your phone. Okay, just flip your phone screen and you will see it is clockwise. Okay, so south pole clockwise and north pole anti-clockwise. So these are the important three things we have to remember in terms of the rotation of the earth. So north pole anti-clockwise if you see from north pole, if you see from south pole it is clockwise, and it is west to east in general. So these are the 3 points. This is the point number 1. Okay, let me just increase the size of the pen. All right, this would do. Okay, this is the point number 1. This is the point number 2, and this is the point number 3 in relation to your rotation of the earth, which you will have to remember, guys. Okay, so we have talked about the rotation of the earth. We have talked about the tilt angle. Okay, we have talked about what is ecliptic plane and normal plane. We have talked about the compression ratio. We have talked about the equatorial diameter and the polar diameter. And we have talked about what is the shape of the earth, which is the oblate sphere or ellipsoid. So these are the general things which you should know as a pilot, and these are the very simple things, and these questions they come for 1 mark, sometimes 2 marks in the DGCA navigation and ATPL examination. And I want you to remember this much information for today as of now. Okay, because the next because if I start talking about the great circle today, it will take me up longer. So I'm not going to do that today. I will make another video for the great circle, but till then just revise all the values. So I'm going to just summarize it in the end what we have done. So we have done the shape of earth. Okay, so shape of earth, we have done about the equatorial diameter and the polar diameter. We have done the compression ratio, which was 1 by 297, equivalent to 1 by 300 or 0.3%. Okay, we have done or talk about the tilt angle, tilt angle of the earth. We have talked about two plane, which is normal plane or a normal plane, orbital plane. Orbital plane is also known as your ecliptic plane, ecliptic plane. Okay, and we have talked about the rotation of the earth. So these are the things we have talked about, rotation of earth. And I want you guys to remember all these three things, all these things, so that in the next chapter or in the next video we will be talking about the great circle. So guys, watch it again. If you don't understand, if you don't understand anything, please write down in the comment section below. All right, because what I'll do is, for your better understanding, right now I was not able to get the 3D images for you guys, but I think these 2D images you should understand it. But while teaching the great circle, I'm gonna try and get the 3D images for you so that you understand it better. Okay, so basic navigation has started, guys. Please do watch the previous videos. I will try and cover all the syllabus before the DGCA navigation exam. If you're watching the video, my request is to please subscribe the channel, because the more you subscribe, the more I get the motivation to make the video. And also, I want you to, if you're watching the video and liking the video, please drop a comment section whether you like it or not like it, or what improvements do you want, or anything that you want to share with me. Okay, so thank you so much, guys, for watching today's video. And hit the notification bell, so when I put the general great circle video, you'll get a notification about it. So thank you so much for watching and have a good day. Thank you.